black box. It just doesn't fit neatly into a computer program or a model. This is stuff that you really have to go out on the land and dig holes for. Now, dynamic soil quality, and I'm going to specifically focus on porosity because that's really the thing that we change the most with our management techniques. And when you look at dynamic soil quality, it's a tool that we can use to evaluate the sustainability of our different management practices. And that sustainability piece is key, because remember, soil is not a non-renewable resource, we consider it. So you have two different factors at play. So you have changes in dynamic soil quality. When we talk about porosity, that's the exchange of gas, water, roots, medium for roots, soil biological respiration. When you start removing that, you don't have the gas exchange, you don't have the moisture. And this would be, say, from excessive passes of a piece of equipment, and it just compacted it down and you lose your pore space. So that's an example of a dynamic soil quality that changes with our management practices. And we have soil best management practices that can alleviate this or altogether eliminate it. And we can go into that later on. And then when we talk about soil texture and permeability, that is also porosity, but they do have inherent characteristics associated with them based on the texture. So if you have a sandy soil, you're going to have rapid infiltration, and then it'll just slowly infiltrate as you get more clay. So a sandy loam is just sand with a little bit of clay in it. So that's the transition of that. And research has shown that if you were to compact a sandy soil, it isn't necessarily negative for sandy soils because it does reduce some of the pore space and it traps more of the water and it retains it in the soil profile for plant availability. But that study was done in the shore pine plantations of North Carolina. So this is beach sand we're talking about. So you really have to know the context of where the study was at. So there can be some benefits for that. But when it comes to sandy loams and you get in more of the clay, that study goes out the window and is not applicable. So again, we have best management practices to make sure that we eliminate this kind of impact, dynamic soil quality impact on the land through our management activities. So if you use both dynamic and inherent soil quality concepts, the result is two very different interpretations that we apply at different times during the, I refer to a forest planning process, but this process can be used in any land management that you're doing. It could be farming, it could be plantation work, right? It could be orchard work. Any time that you're dealing with soil, you can use these concepts to better and have a more holistic approach to your land management techniques. And what we're doing here, this is field measurements for soil porosity and infiltration rates in the field. And we're not burying Terry there, we're actually describing inherent soil qualities there. We do happen to dig down to 6 feet most of the time, but we're not burying him there. So just examples of the stuff that soil nerds do out in the field. So then we take all of those soil inherent characteristics, and we put, as humans, we like to put things into categories in nice orders. So we put them into a taxonomic system, 12 orders of soil taxonomy. It actually is a science. We don't make this stuff up as we go. And then we refer out in the field to the keys of soil taxonomy to figure out where we fall within the 12 soil orders. And then we have the dynamic soil quality characteristics that change through our management activities, and we call it within soil science, we call it suitability capability ratings. So within each one of these 12 soil orders, they each have unique capability and suitability ratings for a wide range of uses that we use the land for. And I'll get into that later if we have enough time. There's a great product that the NRCS has put out. It's called Web Soil Survey, and our county has some of the best soil mapping in the nation. It really is pretty neat. And you might be asking yourself, well, in Washington State, how many of these soil orders do we have? Well, let me show you. I say there's 10 of the 12 soil orders in this state. Now, the one that's red, the Gelisols, that's a permafrost soil. People might be able to debate me with this. A couple of years ago, after the Wolverine fire, I was up at Holden Village on the west side of Lake Chelan, way up on the edge of Glacier Peak Wilderness, and I hiked up to Bonanza Peak, and I didn't have my shovel with me, and I regret not having it. But pretty dang sure I could find a couple of acres of gellosols up there on the margins of those alpine glaciers. I almost guarantee it. So I'm saying we have 10 of the 12 soil orders in Washington State. That's pretty cool, I think. It just shows the rich geologic history of Washington State and really of Okanagan County. The two that we're missing, oxasols, those are tropic soils. Vertisols, those are high 2-to-1 clay content soils. 2-to-1 clays are shrink swell. So if you've ever seen those soil types where they have those big cracks and then it rains and those cracks fill in, that's what the vertisols are. We just simply don't have any of those in Washington State that I know of. Nobody's debated me about that either. So moving on to this conceptual model for, I'm calling it the forest planning and management cycle that promotes soil relevance during the planning process. I'm going to come back to this, and this was derived from the Soil Matters paper. And you start with your land management objectives. What do you want to do with it? Then you bring in the opportunities and limitations based on, and that should say inherent soil quality. So you can do your soil mapping based on those inherent characteristics, and you'll see this in action. I don't want to give away my secrets just yet, because really, it was pretty cool to apply this at Mount Hall, because it worked really well. And then from there, you get into your interdisciplinary strategy for land management actions. And that interdisciplinary strategy really is key because it brings a holistic approach to land management. We bring in the wildlife biologists. We bring in our fisheries folks. We bring in forestry, botany, archaeology. We bring all these people together and we start talking about what's our strategies? What are we going to do? What's the actions? What do we need to see on the landscape for a holistic approach? Everything gets out on the table. We're going back and forth. Then I come back in, or soil scientist, doesn't have to be me, but then I present the soil information for project design and implementation based on those dynamic soil characteristics. What's the risk of the soil for compaction, for erosion, for rutting? What are some of those quality, suitability, capability standards for those different soil types? And this picture here represents this part and this part here, that these soils this is South Summit project over in the Met Howe. These soils were ash cap soils, easily compacted. We were worried about rutting and displacing that ash cap and mixing that in with the glacial till, and that would take away a lot of that inherent water holding capacity of that soil. So we opted for winter harvesting, in this instance, for soil-based management practices to reduce a lot of that risk. We're really good at harvesting over snow up here. We have a lot of great soil BMPs. And when that snow melts away, the only way that you can tell we were ever there was stumps. There was no compaction, there was no rutting, there's no track marks, there's nothing. It works really well. So it's something that we do on the Forest Service side of things to help our strategy for this part here. And we were out monitoring for success, and we were really good at it. And it is recognized that there are many complex concepts of soil quality, and a lot of the times it can be difficult to organize and apply those in the forest planning process. And sometimes you could be in a planning area where you only have a couple of different soil types. For an example, I'm on a project outside of Leavenworth. It's called the Upper Wenatchee Pilot Project. And it's in the Upper Chihuahua Basin, and it's basically in the shadow of Glacier Peak. So those soils are basically just all ash cap soils because of its proximity to Glacier Peak. There's some variability within the andesol soil order itself, but in that project area in particular, it's all ash cap soil. So there's not a lot of difference there. Whereas the Mount Hall project, you're going to see quite a bit of difference.